Hey friends, welcome to the YouTube channel All About Electronics. So we know that the PLCs or the programmable logic controllers are the integral part of any industrial automation and the process control. So in this video, let us understand how they are different from the microcontrollers. So this PLC or the programmable logic controller is the industrial controller which consists of the following modules. So if you see in the heart of it, then it consists of the CPU and the relevant program and the data memories. And apart from that, it consists of the input and the output modules. So through this input module, different sensors and the switches can be integrated with the controller. And through this output module, different actuators can be switched on and off. And of course, to program this PLC, we have a programming device and the HMI. So typically, to program this PLC, we have a computer or the dedicated programming device. And to monitor and control the different process parameters of the PLC, we have the graphical display with the touchscreen or the keyboard. So this graphical interface is known as the HMI or the human machine interface. And finally, to power up all these modules of the PLC block, we have the power supply module. So typically in the PLC, all these different blocks are modular. That means depending on the one's need, one can add the required blocks. For example, in some industrial application, if it is required to add more input and output modules, then another IO module can be easily integrated with the existing system. Or if it is required to add some communication modules or some special purpose modules, then they can be easily integrated with the existing system. On the other hand, in the microcontrollers, all these different blocks are integrated in the single chip. So once the microcontroller is selected, then typically it is not possible to add the additional features in the same chip or the board. But using the additional chip or the additional shields, it is possible to add some features to the existing board. So for example, in the given microcontroller, if we want to add the additional IO ports, or if we want to add the additional relay module, then using the external shield, it is possible to do that. But for that, we need to do the additional wiring with the existing microcontroller chip or the microcontroller board. While in case of the PLC, it can be done very easily. The second aspect, if you see, then the PLCs are designed for the harsh environment because mainly they are used in the industrial automation and the control systems. So therefore, they are quite rugged and they can withstand the shock, dust and the humidity without compromising the performance. Moreover, their operating temperature range is also typically higher compared to the normal microcontroller boards. Not only that, the inputs and outputs of these PLCs are also opto-isolated. So because of this galvanic isolation, they can withstand the higher current and the voltage surges during the operation. And moreover, they also have the EMI and the surge protection circuit for the additional safety. Not only that, all the commercially available PLCs also provide the different safety certifications for the industrial usage, like the electrical safety, EMI and the EMC compliance certificates, and the functional safety certificates. And this certification indicates that it can provide the guaranteed performance during the harsh environment. On the other hand, the microcontrollers are mainly used in the embedded systems, consumer applications, and the prototyping projects, and therefore they do not provide any safety certificates. So, therefore, they do not provide any safety certificates and they do not guarantee the same reliable performance as the PLC under the harsh environment. So, in some applications, if it is required to use such microcontrollers in the harsh environment, then the separate care must be taken and the additional circuit should be integrated with the existing microcontroller boards. So as I said, the PLCs are complying with the different safety standards. That means they have the built-in redundancy and the fault tolerance. And to implement that, they have the different watchdog timers, redundant CPUs and the power supplies. And not only that, these PLCs also perform the different error checking on the IO modules. On the other end, the microcontrollers do not have such redundancy. So of course, they do have the watchdog timers, but they do not have the built-in failover mechanism. So let me explain what do I mean to say. So in the microcontrollers, what does this watchdog timer do? They used to communicate with the MCU at the fixed interval. And if the MCU does not output the signal after the specific interval, then the watchdog timer determines that the MCU is malfunctioning. And in that case, it sends the reset signal to the MCU. So most of the time, when the MCU gets reset, then it starts working normally. But in case of the major failure, it is quite possible that even after resetting the MCU, it will not work properly. So in case of the PLC, in such scenario, there is a backup CPU. So in case of the failure of the main CPU, the backup CPU takes the charge and starts operating the system. But in case of the microcontroller, we do not have the backup microcontroller. So because of the lack of the redundancy, in case of the microcontroller, we do not have the failover mechanism. On the other hand, many PLCs also comply with the SIL standards. And under these standards, they can detect the faults, execute the safe states, and maintain the certified operation during the partial failure. While if you see the microcontrollers, then typically they do not comply with the SIL standards. Now, as the PLCs are intended to be used in the industrial environment, so the real-time performance and the safety compliance is very much required. Because if PLCs fail to respond to the event within the specific time, then it can cause the damage in the plant or it can be a very risky for the human safety. So typically, these PLCs provide the guaranteed real-time performance. And for that, these PLCs have the deterministic scan cycle. So if you see the one read cycle or the one scan cycle of the PLC, then it consists of the following steps. That is reading the inputs, executing the programmable logic, and then diagnostic the hardware for the proper functioning. And after that, based on the input, it writes the output on the output module. So this one read cycle or the one scan cycle consists of these four operations. So for the guaranteed real-time performance, in the PLCs, this one scan cycle gets completed in the fixed interval. So depending on the PLC module, typically this scan cycle gets completed in the hundreds of microseconds, or for the slower PLCs, it can get completed in the few milliseconds. But the point is, for the given PLC, we have the deterministic scan cycle. So we know that the PLC will certainly respond to the change in the input after this finite time interval. And accordingly, the process parameters in the plant can be tuned. So that is the advantage of the PLC. So of course, if you see the current generation microcontrollers, then they can also scan the inputs and update the outputs in the same order of microseconds to the millisecond. But for that, these microcontrollers must be carefully programmed to get this deterministic scan cycle. But in case of the PLC, that is the inherent feature. Now if you see the another major difference between the PLCs and the microcontroller, then that is the operating voltage and the voltage range of the I/O modules. So typically, these MCUs or the microcontrollers are compatible with the TTL and the CMOS logic levels, and therefore they operate with either 3.3 volt or the 5 volt. And some current generation microcontrollers can operate even at the lesser voltages. And correspondingly in the microcontrollers, the voltage range for the input and output pins is also typically between the 3.3 and the 5 volt. On the other hand, as the PLCs are meant to be used with the industry compliant sensors, so they support the wider range. So these PLCs operates on the standard 24 DC voltage, which is quite common in the industry. But there are many PLCs which also supports the AC voltage. So in such case, they have the built-in power supply module which converts the AC voltage to the DC voltage and generates the 24 volt for the other modules. So similar to the microcontroller, these PLCs also support the analog input. But here, apart from the voltage input, they also accepts the current input. So if you see the input voltage range, then generally it is from 0 to 10 volt. while if you see the input current range, then it varies from 4 to 20 milliampere. And using this, it is possible to interface many industrial sensors like the temperature sensor, level transmitter and the flow meter. So similarly, it also accepts the digital input. And if you see the digital input range, then it varies from the 0 to 24 volt. That means the logic low corresponds to 0 volt while the logic high corresponds to 24 volt. And using these inputs, it is possible to connect the different switches to the PLC, such as the push button, limit switch, flow switch and the pressure switch. So for example, the flow switch will get activated and will provide the 24 volt output when the flow of liquid exceeds the set value. Likewise, the pressure switch will get activated when the pressure in the vessel exceeds the set value. And accordingly, the PLC can take the action. So that is the digital input. Similarly, it also has the analog outputs. But here, it can provide both voltage and the current outputs. So the voltage output range is from 0 to 10 volt, while the current output varies from 4 milliampere to 20 milliampere. And these outputs are useful for driving the variable frequency drive or controlling the process parameters. For example, the analog output of the PLC can drive the VFD, and then this variable frequency drive can control the speed of the AC motor. So in this way, this PLCs also supports the analog outputs. And finally, it also supports the various types of digital output. So typically, the digital outputs of the PLC are the relay output, and using which it is possible to turn on and off different alarms and the indicators. But apart from that, it also supports the transistor outputs for the fast switching. And some PLCs also has the triac outputs for the fast switching of the AC loads. So in short, the voltage range of the PLC inputs and outputs is totally different from the microcontrollers. Then if we see the another difference between them, then that is how they are programmed. So typically if you see the microcontrollers, then they are programmed in C++ or the assembly language. And nowadays, many MCUs can also be programmed in the Python. So this programming can be done in the different development environments. So these are the common development environments which are typically used for the programming these microcontrollers. So of course, there are many other vendor specific development environments, but using this environment, it is possible to program the MCUs. On the other hand, this PLC programming has been standardized by the following standard. And this standard defines the 5 common programming languages for the PLC. The first one is the ladder logic, which is most commonly used for the PLC programming. Then if we see the second language, then that is the functional block diagram. Then after, if we see the third programming language, then that is the structured text, which is very similar to the high level text based programming like the C language. Then after, if we see the fourth programming language, then that is the instruction list. So this programming language is a low level text based language and it is similar to the assembly programming. And then after, the fifth one is the SFC. So as per this IEC standard, these 5 programming languages are supported by the PLCs. So if you see the development environment for programming this PLC, then that is the vendor specific. But since the PLCs are meant to be used in the industry, so these development environments also have the built-in diagnostic tools. So as you can see, from the programming perspective also, the PLCs and the microcontrollers are programmed differently. Now the another aspect in which they are different is the scalability. So typically, the PLCs are easily scalable. So because of their modular design, first it is easy to attach different modules. And even if you want to connect multiple PLCs together, then it can be easily done by connecting these different PLCs together in the network via the LAN cable. So in case of the microcontrollers also, using some wired or the wireless protocols, it is possible to connect multiple MCUs together. But for that, first the microcontroller unit should support these protocols. So nowadays, Most of the microcontroller units supports the given wired protocols. But for that, we need to do the additional wiring and we also need to do the additional coding to connect them together. And if they also support the wireless protocols like the Bluetooth or the Wi-Fi, then it is also possible to connect the multiple MCUs together in the network. But the thing is, the scalability in case of the PLC is wider compared to the MCUs. Then if we see the another major difference between them, then that is the cost. So the microcontrollers are very low cost. So they are easily available in the market and the development environment is also free. On the other hand, if you see the PLCs, then they have very large initial cost. The reason is that they are quite rugged and they are designed for the industrial environment. Not only that, they are also meant to be used for the longer duration. So typically, once the PLCs are installed, then they tend to operate for 10 to 15 years without much maintenance. And typically, the vendors also provide the good support for the same PLC. So that is why the initial cost of the PLC is higher. And lastly, let's compare them with respect to the processing power. So inside the PLC also if you see, then there is a microcontroller. But as we have seen, they are optimized for the logical operation and the scan based execution. Because in the industry, they are meant to be provide the reliable operation. So typically, the scan cycle duration varies from hundreds of microseconds to the few milliseconds. That means mainly they are not designed for the intensive computation. While in case of the microcontrollers if we see, then we have the wide range of microcontrollers starting from the 8-bit to the 32 bits. So using this, it is possible to perform the complex algorithms very efficiently. So if we compare both the PLCs and the controllers in terms of the raw processing power, then the microcontrollers can perform very complex tasks, but they cannot provide the same reliability as the PLCs. So in summary, the PLCs are meant to be used for the industrial usage, and as they are meant for that, so they are quite rugged and the robust. Not only that, they can also withstand very harsh environment and they also complies with different safety standards. Not only that, their operating voltage range is also industry compliant and they are designed to accommodate wide range of industry sensors. On the other hand, the microcontrollers are very low cost and they are meant to be used in the embedded systems, consumer applications and for the prototyping. And as we have seen, they operate with the low voltages like the 3.3 volt and the 5 volt. But in case of the microcontroller, we have the additional flexibility. That means by building the additional circuit around it, it is possible to use them in the different applications. So I hope through this video, you understood the basic difference between the PLC and the microcontrollers. So if you have any question or suggestion, then do let me know here in the comment section below. If you like this video, hit the like button and subscribe the channel for more such videos.